Welcome back everyone to another video in our FE Civil Preparation course. In this video, we are going to continue with the laboratory and field tests on soil. One of the most important soil tests that must be carried out to any soil sample is called sieve analysis. We use sieve analysis in order to understand the maximum size of soil particles as well as the minimum size. We also understand the grading of the soil size, which is a very important aspect. Based on the sieve analysis test, we will be able to identify the soil classification based on USCS and AASHTO requirements, which we are going to discuss in our next videos. This test consists of number of sieves with standard opening size. The sieves are arranged on top of each other so that the sieve with the bigger opening is at the top and the sieve with the smallest opening will be in the bottom. The soil sample is put in the top sieve and we start mechanically shaking the sieves. After we finish shaking, we start weighing the soil on each sieve and we start preparing our table, as we will see next. In this table here, we will assume a sample size of 500 grams and we will see how our table will look like. We have 8 numbers of sieve here with arrangement as we can see on the left, starting from sieve number 4 with opening of 4.75 mm up to sieve number 200 with opening of 0.075 mm, and in the end we have the pan. And of course the total weight of the sample is 500 grams. We can see here on the first sieve number 4 that the mass of soil retained is 0 gram, which means that all the soil sample passed from the sieve to the next sieve. So the percentage of the soil retained is 0 and the cumulative percentage retained is 0 and the percentage passed is 100. On the next sieve we can see that there are 12 grams of soil got retained on sieve number 2 and the remaining passed, which means that 2.4% of the soil are retained, which is 12 over 500, and 2.4 accumulative because there is nothing else was retained on previous sieve, and the percentage passed will be 97.6%, which is 100 minus the 2.4. On the next sieve, which is number 16 with opening of 1.18 mm, we can see that there is 35 grams got retained on the sieve, which means that the percentage retained is 7%, which is 35 over 500, which means that the percentage retained is 7%, which is 35 over 500, and the cumulative percentage is 9.4, which is 7 plus 2.4, which were retained on the previous sieve, and the percentage passed is 90.6, which is 100 minus 9.4. On the next one, we will keep going with the same. We have 28 grams retained on the sieve, so the percentage is 5.6, which is 28 over 500, and the cumulative is 15, which is 5.6 plus the 9.4, and the passed will be 85. And we will continue doing the same till we reach the last sieve. Of course, in the end, the cumulative percentage retained will be 100, and the percentage passed will be 0, and the total weight will come to be 500 grams. Once we are done with this table, we will start drawing our curve, which represents the distribution of the soil sample. The x-axis is the soil particles diameter in log scale, and the y-axis is the percent of soil distribution for each diameter. And from this curve, there are 3 values that we must obtain, which are D10, D30, and D60. So what are those values? D10 is the diameter of soil particle corresponding to percentage of 10%, and D30 is the diameter of the soil particles corresponding to percentage of 30%, and D60 is the diameter of the soil particle corresponding to percentage of 60%. So if we considered for this example that D10 value based on this graph equals 0.05 mm, this means that 10% of our soil sample was finer or smaller than 0.05 mm. And if the value of D30 for the same soil equal to 0.1 mm, it means that 30% of the soil sample was finer or smaller than 0.1 mm. And the same concept for D60. And based on those 3 values, D10, D30, D60, we calculate the following coefficients. First one is the coefficient of uniformity, Cu, which equals to D60 over D10, and the second one is the coefficient of concavity or curvature, Cc, which equals to D30 squared over D10 multiplied by D60. So now, let's have an example on this. So let's check this example. We have this soil sample with this distribution, and we want to calculate the uniformity coefficient of this soil. We know that the uniformity coefficient, which is Cu, it equals D60 over D10. So now we want to calculate the D60 and the D10. D60, we will come here, which at 60%, and we will move horizontally till we hit the soil sample distribution graph, and we will go vertically till we reach at this point. And the same we will do it for the D10. We'll come here at 10 horizontally and then go down to reach here. Now we want to read this value. You have to be as accurate as possible, and of course you have to remember that this is log scale. So if this is 1 and this is 0.1, this means that each one of these is 0.1. so let's start by the 60. This is 0.9, 0.8, 0.7, 0.6, 0.5. It is just a little before the 0.5, so let's call it 0.49. And we will do the same for the 10, D10. We will go from here, and let's calculate this value. Again, it's if we will calculate from here, this is 0.1, so this is 0.2. Approximately it is at the 0.2. So the Cu, it will equal 0.49 over 0.19, which equals 2.6. So this is the answer, number C.